Hi there, welcome to another video from HEGARTYMATHS, a call for Maths A-Level video, another one on vectors. As always, for more help with your GCSE or Maths A-Level, do check out YouTube, Twitter or Google+. This is the 8th tutorial and we're dealing with the three-dimensional vector equation of a line. It's for the Edexcel Core 4 syllabus, applicable to most A-Levels. And here in particular is the Edexcel specification we're dealing with today. We're dealing with vector equations of lines and two forms of those lines. Okay, so let's start off quite straightforwardly by talking about 2D lines, okay, or a normal equation of a line. Here's an XY axis. Say I want to find any point on that line. Say I want to find any general point XY on the line. I could do that or describe that point on the line if I knew two things. Say if I knew a point on the line. Say if someone told me for sure a point on the line. This point here in this case. Okay, say I knew that. And secondly, say if I knew the direction of the line. Okay, the direction the line was going in, so what direction it was going in. In this case, every time I go across one, I go up 2. Every time I go across one, I go up 2. Every time I go across one, I go up 2. Every time I go across one, I go up 2. Sometimes, in 2 dimensions, the kind of equivalent to that is talking about the gradient. Okay, so say if I knew the gradient, in this case, the gradient must be 2. Or I could write that as a vector. Every time I go across one, I go up 2. I could write it like that. Say if I knew those two things about a line, I could find any point on the line. Any point on the line xy, a position vector xy, must be the point where I started, and this point here is 0 cross 1 up, plus some lots, let's call it t, t is just a number, of the gradient, 1, 2. So I can find anywhere on the line by finding myself to the line, and then going a certain lots of the gradient to get there, or a certain lots subtract of the gradient to get there. So for example, this point here is actually the point 1, 2, 3, 4, 9. Now how could I find myself to 4, 9? Well, I get to the line, 0, 1, and then I go 1 across 2 up once, 1 across 2 up twice, 1 across 2 up 3 times, 1 across 2 up 4 times. I go 4 lots of the direction of the line or the gradient, and by doing that I get 4, 9. Similarly, I could find myself like to this point here. Say I want to get to this point here, which is 1, 2, 3, negative 3, 1, 2, 3, 4, 5. This point here is negative 3, negative 5. How could I find myself to the position negative 3, negative 5? Well, I could start off at 0, 1, and I could go 1 back, 2 down, 1 back, 2 down, 1 back, 2 down. I could subtract 3 lots of the gradient 1, 2, and I would find myself to the same point. So any point on the line, right, is if you want to define any general point on the line, this is a general point. It's a particular point on the line plus some lots of the direction. Okay, some lots of direction. Okay, and this is what we're going to use in 3 dimensions. So let's move to 3 dimensions to extend this idea. This time, obviously, suppose we have an axis, a 3-dimensional axis like that. Okay, I might get rid of this in a second. So everything's in 3 dimensions, and suppose we've got a line. Okay, so I'm going to get rid of that. It's not going to help the picture, but we're in 3 dimensions here, and imagine we've got ourselves a straight line. So to some extent, that's going across the page, up the page, and into the page. It's going in 3 dimensions. It's going that type of thing. Okay, so imagine it's going in that sort of way, right? And actually, if I keep that to the side just to remind us of that, we don't need it on the picture. We usually say across is the x-axis, up is the y-axis, and into the page, that type of thing, is the z-axis. And the vectors, the unit vectors associated, that would be I, j, and k. Okay, but let's not worry too much about that. Now, imagine also you have the origin. The origin is some point sort of down here. That's the point origin. It's the point 0, 0, 0, and you call it the origin. Okay? Now, any general point on the line, I'm going to call R. Okay, and R is going to be equal to, let's call it x, y, z. X, y, z. The position vector to get from O to R is going to be x, y, z. This point here in space is x across, y up, and z into the page type thing. Now, the question is, how could I find myself there from the origin? Well, in the same way in the last slide, I needed to know two things. I needed to know a point on the line. Okay? Now, a point on the line, let's say we know a point on the line. This point is on the line. This is point A. Right? And therefore, let's get ourselves to the line by going like that. This vector here is the vector OA, which we call little a. It's a position vector. So now we're on the line. Now suppose also we knew the direction the line was going in. Okay, so the line was going in direction B, let's say. Okay, so vector B gets us there. So secondly, we know the direction of the line. Okay, how could we get to this point here? Well, surely you can see that R, to get to there, well, firstly we must go to point A, which I'm going to call little vector A. I'm going to find myself a point that I know is on the line, and I'm going to go some lots, let's say T, lots of the vector B. So to get here, I get myself to the line by going the position vector of A, and then I might go 1, 2, 3, 4, 5 lots of B. Or to get back here, I might go -1, -2 lots of B. Or to get here, I might go 1, 2, 3, 4, 5 and 3/4 lots of B. So any point on the line in general is equal to, and this is the vector equation of the line, R is equal to A plus TB. Now the important things, what these are, A is a position vector of a point on the line. B is the vector, or the direction vector even, the direction vector of the line. And T lastly, just to get T sorted in our heads, all T is not a vector or anything. T is just a number. It could be any number. Okay? Okay, so let me just explain a couple of things to you. Say I gave you the vector equation of a line. Say I told you that the vector equation of a line was equal to 1, 2, 3 plus T lots of -2, 0, 4. I said that to you. I told you that. What is the obvious point that's on the line? Well, a point, for any T number, for any T, if I put a T as 0 in there, then I know that 1, 2, 3 is a point on the line. If I put T is equal to 2 in there, I would know that 1 plus -4, 2 plus 0 and 3 plus 8, i.e. -3, 2 and 11 is on the line. For any number of T, I can substitute that in, work this out, and that's a point on the line. So the easiest point on the line is that one. Okay, that's the point to get us to the line. Now if I ask you the direction the line's going in, you need to be able to know it's the vector that gets multiplied by the parameter, the T. This is the direction the line's going in. So if anyone's saying, is this line parallel to another line, this is the one you care about in terms of direction. Okay? You substitute a T number in to find any point on the line. So again, let's just make that clear. If T was equal to, let's say, 4, right? Find a point on the line. Well, R would then be equal to 1, 2, 3, and it would be 4 lots of this, so it would be -8, 0, 16. Okay, and you combine them and it would be -7, 2, and 19. That would definitely be a point on the line when T is 4, and T can be any number. If I ask you the direction of the line, then you would tell me straight away it's -2, 0, 4. That is the direction. Okay? Right, let's have a go at a question. So we're going to use this now, this vector equation of line. The equation of line is a position vector of a point on the line plus some lots of the direction of the line. Right, let's have a go. Find a vector equation of a straight line which passes through point A, this is the point we know, with position vector 3i minus 5j plus 4k, and is parallel to the vector this one. Now we're told everything we need here. A has position vector 3i minus 5j plus 4k, so the little vector A, to get from the origin to that, it tells you the position vector already. That's equal to 3i subtract 5j plus 4k. We prefer writing this as columns, so I'm going to write this as 3, negative 5, 4. Right? Now, it tells you that the line is parallel to this vector, i.e. it's telling you in a roundabout way the direction of the line is that, because if it's parallel to that, it has the same direction. So our B in this case, our direction vector, must be equal to 7i plus no j's, 0 j's, minus 3 k's, which we might write instead as 7, 0, negative 3. Now we know that r is equal, the vector equation of line is equal to the position vector of a point on the line plus t lots of the direction of the line. We have everything we need here, so r must be equal to 3, negative 5, 4 plus t lots of 7, 0, negative 3, and you're done. Now what you might do, you might actually combine these. Sometimes it's helpful to write these combined. Here we've got 7t, no t, and negative 3t, and you might add the vectors, so it's 3 plus 7t, negative 5 plus no t, and 4 subtract 3t. Sometimes these two are just equivalent to each other. Sometimes it's easy to write in that way, sometimes that way. And there we go, there's the vector equation of a line. For any t number, if I put t as 0, 10, 15, 2.5, anything, I will get a point on the line. Okay, just one way of talking about another vector equation of a line is very, very similar. Suppose we have a vector equation of a line, and again, we are trying to describe a point on the line R, and that has a position vector x, y, z. We're trying to get to that point. This time, you remember previously we knew a point on the line and the direction of the line. Suppose we don't know the direction of the line. Suppose we just know two things. Suppose we know a point on the line, which I might call the point this time C, just to make it different. I know the point on the line C, and I know another point on the line D. Okay, and obviously, as always, my origin is somewhere on the page. That's my origin. It's at 0, 0, 0, and it's called the origin. How could I find the vector equation of this line? Now, say I knew the point C, so I could find myself the position vector O to C and the position vector O to D, which I might call little c here and little d here. Okay? Now, how could I describe this line? Well, previously I needed a point on the line plus the direction of the line. Now, we don't know the direction of the line, but look, we can find it. If you want to find the direction of that line, the direction of this line must be the vector CD. Mustn't it? Okay, to get from here to here is going along the right direction. And the vector C to D is negative D plus C. Sorry, to get from C to D, sorry, it's negative C plus D. So it's equal to D subtract C. Okay, so now we've got the two things we want. Remember previously R was equal to a point on the line plus T lots of the direction of the line. Let's use the same idea. R would be equal to a point on the line. Well, we've got two position vectors of points on the line. Let's just use C. R would be equal to C plus T lots of D minus C, which is now the direction of the line. Okay, so what we can do is in a question like this is straightforward. If we have two positions on the line, we can subtract them to get the direction of the line, and then we're home dry. Then we just use one of the points on the line and some lots of that direction. Okay, so we'll do an example of that now. There's nothing really new here apart from one step extra to find the direction, i.e. doing D minus C. Find the vector equation of the line which passes through the points A, B with coordinates as follows. So it might always be helpful to draw yourself a picture. Okay, you're trying to find the direction of that line. here's your origin. Say for example here you've been told this is 4, 5 minus negative 1. Up here you've been told this is 6, 3, 2. And in general you're trying to find r is equal to x, y, z. You're trying to find the general equation of a line. Now, in order to find that, this is going to be my vector. If this is point A and this is point B, I'm going to call this little a and I'm going to call this little b. And what we can do is, if we want to find A to B, it's going to be vector B minus vector A. And vector B, I'm writing vector form now, is going to be 6, 3, 2. And you're going to subtract 4, 5, negative 1. So it's going to be equal to 2, negative 2, and 2 subtract negative 2 would be 3. I.e., how do you get from here to here? Well, you've got to go 2 across, because 4 to 6 is 2. You've got to go 2 back, from 5 to 3 is negative 2. And you've got to go 3 forwards, okay, because minus 1 to 2 is 3. Okay, so there's the direction of the line, and therefore R would be a point on the line. Let's just use A, it's easier. You could use B, it doesn't matter. It would be 4, 5, negative 1 plus t lots of 2, negative 2, 3. Okay, and you could combine these like I said in the previous video if you really wanted to, it doesn't matter. You could say that's 4 plus 2t, just expanding this and combining, 5 subtract 2t, and negative 1 plus 3t, and we're done. Another example, a straight line has vector equation as follows. So let's just think what that means. That is a position vector of an easy point on the line. This here is the direction the line's going in. T is just a number. Okay, T is all T is a number. Given that a point A, B, 0 lies on the line, find the value of A and the value of B. Now, R, writing it in column form is probably easier, is 3, 2, negative 5 plus T lots of 1, negative 6, negative 2. Now when you're trying to find a point on the line, it's easier to combine these vectors and write that as 3 plus t, 2 subtract 6t, and negative 5 subtract 2t. Now that's any point on the line. Remember what this is. This is any position vector of a point on the line of point on line for any t, Now, I'm told that AB0 lies on the line. So what I could do is I could say that 3 plus t, 2 subtract 6t, and negative 5 subtract 2t must be equal to AB0, because that point is definitely on the line, right? Now, if I could find a t that makes that work, then then this point is on the line. I could find A and B. Now, for these to be equal, this has to equal this. This has to equal this, and this has to equal this. So the easiest one to deal with is to say that negative 5 subtract 2t must be 0. Add 2t to both sides. Negative 5 must be 2t, and dividing by 2, t must be equal to negative 2.5. Right? And now I can just substitute t in here. So therefore, if that is our t, okay, then this equation, 3 plus negative 2.5 would be negative a half. 6 subtract 6 times 2.5, so it would be 2 subtract 6 times negative 2.5, and I get myself 17. And we know this is equal to 0. So that must be equal to A, B, and 0, substituting in. So that's telling me that point A here must be equal to negative a half, and B must be equal to 17. Last example now, here's a tricky example, just to make sure we understand everything. A straight line has vector equation that follows. So this is a point on the line, and here is the direction the line's going in. Show that another vector equation of the line is equal to this. Okay, I suppose if I want to show this is the vector equation of the line, I need to show two things. Firstly, I need to show that is a point on the line. because that I have to prove that AI plus 3j plus k is a point on the line. Secondly, I must prove that this is indeed the direction of the line. Okay? Now, using r is equal to 2i plus 5j subtract 3k plus t lots of 6i subtract 2j plus 4k. Okay, could I find a t that gets me this point here? Well, look, if I let t equal 1, then r would be equal to 2, 5, negative 3 plus t be 1 lot of, be just 1 here, it would be plus 6, negative 2 and 4. And hence I get myself 8, 3 and 1, and so therefore this is 8i plus 3j plus k. You remember this is true for any t. If I happen to choose t as 1, that verifies that this is indeed a point on the line. So this is a point on line. Now all I've got to do then is check that this direction's right. Well, look, this is the direction I know is true. I know that 6i, let's do this in a different colour pen actually. I know that 6i subtract 2j plus 4k, okay, I know that's the direction of the line. Say if I factorise a 2 out, I would have 3i subtract j plus 2k. Okay, so therefore these two directions are parallel. That and that are parallel because that's twice that. So therefore 3i minus j plus 2k is parallel to 6i minus 2j plus 4k, which was the direction we're given. Therefore is direction. Okay, you've shown that point's on the line. You've shown this is the same as that direction, hence you're done. And we're finished for this. So just to tidy everything up, make sure you read chapter 5, page 75 to 78, and please complete exercise 5H. Thanks for watching.